Welcome back. So in our last video where I was trying to define what a recursive function is. So a recursive function is a function that is defined using base functions that are already recursive functions that are already said to be that have already been calculated. You don't need to prove anything, you just put them. That's why we call them the base functions. And then another that we call the règle de construction in French, which I think should be the constructive rule. So I repeat, like I said, a recursive function is a function that is defined. I'll put that down here. So a recursive function is a function that is defined using using base functions. In French we say fonction de base. Let's bring it up a bit. Okay, and then the second we said règle de construction. So this is fonction de base, and this is a constructive rule or règle de construction. So these are the two ways in which the two branches that leads to us having a recursive function. So the next thing we're going to look at, we're going to talk about the fonction de base and the règle de recursion. We're going to break them down. We're going to explain them separately. But before we do that, let's talk about the notation. That's the notation that we use to define a function. So we can use notations to define functions. In this case, we're going to use the one we call the Lambda notation. Okay, do that in my ink. Lambda notation. We use the one which we call the Lambda notation to define the function. So let's say, for example, I have a function sum, that's addition. I have a function sum. Normally I'll define it as, let me say a sum of two numbers. That means I'm having two variables, right? So I'll have, let me call the function plus. So I have n derivé 2 of n. I have two variables, so this is derivé 2 x, y, and I'm having it defined as x plus y. This is how we do it. But now if we're using the Lambda notation, it makes it shorter, but then you understand the concept, you understand what the definition is actually talking about. So when we're using the sum function, what we basically do is we write the function name and say it's equal to lambda xy. Lambda xy is representing this first part. So lambda xy is representing the first part, which we have there. Then x plus y, which is representing this part. And that's how we basically note the notation for functions. This is the general definition. That's the plus. This is the general definition, and this is when we're using the Lambda notation. So x and y, we say they are the variables, and then x plus y is the body of the function, is where the building of the program is where you get to put in. The beginning is like a x y, and then the sum x plus y. So x y is they are the variables, the arguments, where you can also get the number of your arithmetic from, and then x plus y is now the body of the function, the sum. So now we'll be looking at fonction de base. Looking at fonction de base, we have basically three functions de base from which we can construct other functions that we want to calculate. So we have, let's just write, there are basically three functions de base. From these three we can get to construct other functions. The first is the successive function. That's la fonction successeur, noted as S. So the first, la fonction successeur, notée S. The first is the function successor, which we note as S. So that means, like, from the notation, let me bring us back to the notation, because sometimes I might not be using the general definition, which is this way. I'll be using this way instead. So I think we should get used to this. So basically we know what this means. If I have n of arithmetic 2 and then n x plus y is basically the function, defining the function. So using the lambda notation, I have it as plus is equal to lambda extra, which is naming the function, then the full stop sign, and then x plus y, which is defining the body of the function. That's exactly what I'm going to do in this case, so I won't have to define this the general way. So I should use a red pen. So I have S is equal to lambda x plus 1. That's successor. You know, when you successor, like what follows it, you have 1, the following number is 2, you keep adding 1. That's what we also call the la fonction successeur. So you can also put the notation, the lambda notation, in your record book, so you'll be able to follow this from as we go on. And can we guess what the arity of this function would be? Okay, for those that guessed 1, you're correct, because we have just one variable, which is x, and so it is of arity 1. So it's arity 1. Now, the second fonction de base, because we said we have 3, the second fonction de base is the one we call la fonction identiquement nulle. La fonction identiquement nulle. I'll write that down as well. La fonction identiquement nulle, and we note it as z. So la fonction identiquement nulle, noted z, it's defined. Remember I said these ones you don't have to prove them because they're already the base functions. So all this, I'd advise we put them in our record book, so from time to time we can come back and do a bit of rappel or revision on it. So this is lambda x 0, that's for la fonction identiquement nulle. You can also guess again what is the arity of this function. Again, those that guessed 1, they're correct because we're having one variable, and so we should have d'arité 1. So the third base function is the one we call the projection. So the third one the projection, and we note it as this might be looking a bit weird, but I'll explain it. So the projection de P-I-K, it's noted as this, is the projection, like if the I represent a certain location as well as K, like certain location, and then all you have to do is tell you, give me the projection from, give me the function that you let's say you're in a class, for example, and they say give me, or let me use back then in secondary school, we used to have houses: the blue house, the red house, the green house, and yellow house, basically those colors. And then let's say they'll bring an individual like from each house to stand on a straight line, and now there are 4, right? There are 4: red, green, red, and yellow. And then you're asked to give me the third person in the group. Like I said, I need red, green, red, yellow. So red is the third person, and you're like, give me the third person among the 4, like out of the 4 standing there. And that's basically what the projection is all about. You're just picking out the function out of the other ones that are being placed in a certain place. Yeah, so that's the layman kind of definition that I suppose I can bring to the table. So you have that. So you're asked to bring out of K functions, out of the 4 houses, that's K in this case, out of the 4 houses, you're asked to bring out the third person standing on the line, and it happens to be the red. So it's going to be I will be 3, which is the third person, K will be 4. Yes, so that's basically what the projection is all about. So projection, I'll define it with a function, and so we'll have, using our Lambda notation, Lambda x1, x2 jusqu'à xk, xi, for every k and for every e from 1 to k. And so remember I said if you're given a projection, maybe P1, P2, P3 up to Pn, and you're asked to bring out the third projection, you just bring out P3. That's all projection. That's basically what the projection is all about. And so in this case, to make it look clear, I think I should write the general definition that's not using the Lambda notation in this case. It's just, this means like n of k, so I have my function n of k to n. So that means this function is what? D'arité k, d'arité k, yeah, and x1 jusqu'à xk, x1 jusqu'à xk de xi, pour tout i from 1 to k. So you're starting from 1 to k. So x is basically the answer, like the projection in which you're bringing out. So let's give an example here. So if I have example, if k is equal to 1 and e is equal to 1, you know, it will have p n puissance raised to the power of 1 vers n, and so we are going to be having just one function, one variable, var x. Can I do this? Okay, so if we look here, we see we're taking e is 1, k is 1, so we're having n raised to the power of 1 var n, so we're going to have just one argument, which is x. We can just call it x var. Since we are picking out, that's the only variable we have, which we bring it out. In this case, it's called the function identité, the identity function, like the mirror, and then you're looking at yourself from the mirror, the same image and all those things. So it's called the function identité. Note it as this as the function identité. Now let's try another example. For this, probably you can pause the video and try and get this yourself. So if k is equal to 3 and e is equal to 2, that is, when they tell you e is equal to, that means they are telling you to bring out the second projection. So you can pause this video and then try and see if you can get it on your own. So this is P2, 3. So we're having derivé 3. So we're having 3 variables, and we're asked to bring out the second projection, which is x2. So the remark we did earlier on, that the functions that have arity 0, are function calculable. That's, you don't have to do anything as well. They're just like, we don't place the functions that arity 0 in the function de base, the base functions, but it's also another one that I'll just pick, like one that is just outside the base function. It's already there, it's calculated. If you see something in that case that it is 0, by convention it's a recursive function. And as well as I just want us to not try and confuse the constant with the derivé 0. Okay, constant, we don't have okay, I don't think I don't want us to confuse and think that the constant, they are different, like it's different like derivé 0. Okay, what I'm trying to say is the functions that are derivé 0, they are the ones we call the constant functions. So it's not like they are different, so don't get to confuse yourself. So the functions that are derivé 0, they are the constant functions. So when you have a constant function, automatically it's derivé 0 by convention. So in our next video, we are going to be looking at the règle de construction. We've talked about the function de base in this video. In our next video, we'll be talking about the règle de construction. The règle de construction is divided into two: the règle de composition and the règle de recursion. That's règle de construction. The constructive rule is divided into the into composition rule and the recursive rule. So I'll see you in the next video. Thank you for watching.